I'm saying this, but I think I'm finally heading to the next day. Took only 5 days to get day 22 done. But it was quite fun. I learned a lot of things. In just that one day. One handmade day. Anywho, okay, I think we can move ahead. Looking forward to the next one. I mean, these are getting really good. Nice. Do some refactor after. I need to do a lot of refactor as well. Maybe. Yeah, no, I think definitely need to. Alright, let's go.
And then a start recording. There we go. Welcome everyone to Handmade Hero. We are here on day 23, which basically maps to 23 hours on stream. And we are closing in on the end of our work with the Win32 platform layer. We finished substantively all the stuff we needed to do last week, but this week we are basically spending a little extra time to do some fun and pretty powerful stuff with it. So the past 2 days I showed how you could have your C code be dynamically reloading all the time, so that basically you never have to close the game and reopen it while you are tuning. You can just go ahead and update your code and it live updates directly. So like basically just like everything you might want from a scripting language, you can just get straight ahead with C code, which is pretty awesome. And we played around with that a bit and it's working really well now. It works under the debugger and it reloads instantaneously. So I'm pretty happy with how that turned out. But today I wanted to show how to do something even cooler that I've actually never seen done before. I mean, I've done it before, but I've never seen anyone talk about it or mention it. So I don't know if other people are doing it and I just have never seen their write-ups, or if maybe they're doing it and they just never told anyone. But I'm kind of excited about it because I don't think anyone's ever actually presented it. Maybe not. We'll see. But it's pretty exciting, I think, because it's a really cool feature that you can do very easily if you've architected things properly. It's actually very difficult to do if you haven't. But since we've architected things properly, it's going to be very easy for us to do, I suspect. So with that in mind, welcome to Handmade Hero Day 23, where we code an entire game from scratch using no libraries and no engines or anything, just so we can see how absolutely everything works in an entire game stack. Which I think is very educational and also very empowering, because it means you can always write anything you need to. Even if you are using an engine or a library, you can drop right down in there and fix stuff if you need to, or write your own stuff if the engine falls short or something isn't working. And it just allows you to understand how engines are working, and it allows you to better sort of manage them from your side of things. So even if you are using engines or libraries, knowing how all this stuff works under the hood can be a very, very powerful tool when the time comes. So with that in mind, if you have pre-ordered the game, you should have gotten a link in your email where you can download a zip file which has every single day's source code in there. So if you want to, since we're on day 23, you can unzip day 22's source code. And when you do that, you will be in the exact same place that I am right now. Okay, so I'm going to go ahead and jump right into it because we have a lot to do today to get to the thing that I want to show you. So let's get started. Basically what I want to point out now is what we did, it was a pretty darn cool. We basically do have, most of what I would want for something where you can do live code editing, right? I can run the game, and we've basically shown this sort of simple, we don't really have, since we haven't been working on the game, we've just been working on platform code and stuff like that, and all the sorts of things that we need to do to support the game on Windows. We basically haven't had a chance to do much in the way of an actual game, but of course we have demoed the fact that we can live change anything that we want, and it immediately updates pretty much instantaneously upon change in the editor. So that's pretty awesome. But if you think about what happens, in a game, usually, like we've just got this kind of toy thing running over here, but pretty soon, over the next month or two, we're going to be building actual game stuff, and there's going to be a real game running in here, and things won't be so simple in terms of actually being able to see the results of code changes, right? Basically, what's going to happen is we're going to have user input, and they're going to be moving a character around, and they're going to do stuff, right? And so I just want to quickly create a little very simple example of what that's going to be like, just to point out where we're going to run into problems with this live code editing. And to be fair, it's not anything wrong with our live code editing. Our live coding at this point is as good or better than mostly anything I see out there in other stuff. So our live code editing is good right now, but I want to make it way better. I want to make it so much better that it's going to be like you would not dream of using something else after you saw this, if that makes sense. But in order to demo why this is going to be cool, I just need a little bit of something that uses some user input or something so that we can kind of see what happens when you actually want to tune something in a game. So I'm going to go into here to our sort of stand-in game code that we did that's just sitting here waiting for us to start writing a game in it. And what I'm going to do is inside, you remember we have our game state thing where we store some state. I'm just going to add like a very simple player X, player Y, just so we have like a location where we're pretending the player is, right? And then I'm just going to flat out say, all right, when we come in here and initialize that, I'm going to pretend the player is somewhere. I don't know where. He's at 100, 100, let's say, right? Just something real basic like that. So the player starts out at some random location on the screen. Again, we're not thinking this through. It doesn't matter. This is just a simple example. And then what I'm going to do here is I'm going to do inside of our code for the keyboard handling or the non-analog handling, basically. I'm just going to go ahead. Well, you know what? I'll just use that stick average X and the stick average Y. So I'm just going to go ahead and for any controller, no matter what it is, I'm just going to go ahead and take the player X and the player Y, and I'm just going to add to them whatever these stick values are. Like it just, again, I don't even care what's going on here. I'm just gonna do that straight away. And then when we do render weird gradient, I'm also going to have a ridiculous function called render player. This is like player in real big quotes here, which will basically just be, excuse me, something that draws anything, whatever we can think of, to the player location. Now, of course, we already have some code in here, and we'll be writing our own rendering code very soon, so we won't have to be so slapdash and sloppy about this. But again, so, you know, one thing at a time, we got to go in order. So basically, we have this Win32 debug draw vertical thing, right? Which basically just kind of goes through here and does this does this nonsense, right? Basically, what it does is it'll draw one vertical line, and we were using it to draw these hash marks, right? So what I'll do is I'll just do something which basically, basically does that. I'll just do something which let's see here. Okay. There we go. Something that basically just loops through the X and Y. In fact, you know what? Now that I think about it, I don't know if this would be easier. Well, nah, probably not. So basically, I'll just do something that loops over some X's, right? It'll start, let's say, at the player X. It'll go to the player X plus 10 or something like this, and it'll add to X. So just the most basic thing you could possibly imagine. And this thing will basically be top will be player Y, and bottom will be player Y plus 10. So I'm just making a simple 10 by 10 rectangle, and I'm going to go ahead and fill that stuff in. Now this will full-on crash if the player moves outside the window. So this is the like absolute worst code you could possibly imagine. Okay, this is never code we would even dream of putting in the app. I'm literally just slapping in there because we haven't written a render yet, and I just need to put something on the screen. So I need to basically pass in a player X and a player Y here. And then let me take a look at actually what I don't actually remember what these calls are here. So it's buffer memory. We're going to need buffer bytes per pixel, although we actually don't even need that at this point because I don't know if we're going to basically fix that value. This is basically 4 here, but I can go ahead and add that to our thing since it seems like it might be nice to just have it there for code that could work either way. Let's go ahead and do that. So I'm going to go in here where we pass that buffer to the game, and I'm going to go ahead and add that in there. So this right here, buffer will be bytes per pixel. Oops, bytes per pixel, bytes per pixel. And then I'm going to take a look at compiling this. All right. So the color for the player, I don't know what color the player should be. Maybe the player will just be a white rectangle for now. The back buffer is just buffer at this point. Render player now needs to get called by somebody. So we go down here, and we will just do it right here to render the player. Okay. So basically just a quick 5-minute thing here where we actually have something going. So I don't know if this will work. I just kind of slapped it in there, but there is my player. See it right there. And I do not actually know if I can move him. Okay, I can. So I have my gamepad here, and you can see that I can move my player around. Of course, it's a little wonky because I've got the stick mapped wrong. let's go ahead and I didn't think about that. The Y direction of the stick, up is actually up is positive and down is negative. So we're gonna have to go ahead and reverse that there. But yeah. So I've got this little guy and I'm moving him around, right? So basically, just imagine that this, and I should probably turn off the gradient motion and for God's sake turn off the sine wave. So maybe let's just say that
I've
game
been thinking
output
of that
sound
too.
from now on. Let's go ahead and pretend that we're just quiet. We just don't need all this sound happening.
I mean, I've been thinking of switching off that sound too. That's funny.
So let's go ahead and basically do this here. There we go. So instead of computing that sine value, let's just do quiet, because that's going to get real annoying. All right. So anyway, here's our little guy who's moving around. Why did that? That was a little odd. I feel like that's a little odd. There's a bit of a frame rate. Did I do something stupid there? I don't know if I did. You can see, I don't know if you could see that, but basically I was getting a weird kind of frame rate hitch happening there. I don't actually know why it is. I think that it's weird because our game still is running at 33 milliseconds per frame. All right, so we'll have to take a look at that a little bit later. Although that may again be, sometimes OBS creates a lot of problems for frame rate stuff, so it's hard for me to always know whether it's something we need to look at or not. But basically all I did is, right, I just made a little rectangle here that I can move around the screen. That's it. And so what I'd like to do is I'd like to be able to, I just needed something where I could show sort of what a game would normally be doing, so I can show what's difficult about tuning code. So let's say, right, that what I want to do, now that I've got this, is I want to implement a way that this dude can jump or something like that, right? I want to have it so that when you push the button, the dude jumps. And so I'm going to go ahead and just implement something simple there, like if action down, right? We've got this action down thing happening. So if action ended down, then we're also going to pretend that the player, you know, jumped here. We're going to discontinuously move him up the screen by 10 pixels or whatever for right now, right? So I've got my guy, I'm moving around. I hit the button, and you can see when the button goes down, right, he jumps, right? And he doesn't come back down or anything, right? I'm just showing you kind of what the deal is. So that's it, right? Well, let's suppose now that we want to work on our code for the jump. So you can tell that the jump is ridiculous. It's totally stupid. In fact, all the player movement code is awful. So what I would have to do if I was doing this live, right? If I was tuning this code, even with our live code editing, here's the process that has to go through it. All right, well, what happens with the jump? Well, I push the jump button, and he doesn't come back down. So I guess I need to add like a timer or something in here or something like this, right? So I'm going to have a timer in the game state. I don't know, something that's like maybe a velocity, right? So I've got a player velocity in Y or something like this. And I'm going to set that to something, and then I'm going to change it over time. Or maybe I just have a timer. So like I just have a T-jump timer. I don't know, something like that. So then I come in here and I go, all right, the T-jump timer is going to be, I don't know, the game state when he jumps. The T-jump timer is going to be equal to 1 second. And then basically, like, you know, I don't know, we add the sign of the T-jump timer, kind of a thing like this. I don't know what's going on. And I do that, and then every time we go through the frame, I subtract something from the T-jump timer. You know, I don't know, something like this. I don't even know if we're passing the frames per second in here or anything like that, but you get the idea. Like I'm gonna have to do a bunch of coding in here. Let's see here. I've got to actually add that inside there. So I'm gonna have to do a bunch of weird coding in here to make this jump code actually do something. So when I'm actually doing it, I have to then make those changes, come back in here, push the button. Okay, like that didn't do anything, right? And of course, it makes sense it didn't do anything because I'm not multiplying this by anything. So I have to come back out here. And I guess since we're doing the live coding, I could leave it running, right? I can leave this guy running, and that's fine. But when I come back in here, I have to do like, okay, I edit it, right? Recompile, and now the code is live or whatever, but, oh, although we have a, oh. I may have to actually make this guy, I may have to actually prevent this guy from running out of bounds. Like I said, this guy will run out of bounds whenever the player actually gets to the bottom of the screen. So I may have to do an actual attempt here at preventing this guy from actually running out of bounds. So let's just do something really simple, which is if the pixel pointer is in bounds, it will do it. Again, this is absolutely horrid code. I apologize for being so horrid on the stream, but I just want to. I'm literally only doing this to show kind of why we want the thing that I'm going to show you how to build. Because if we had already written the game, then it would be very easy to show, or had some part of a game running, it would be very easy to show why the thing that I want to do is interesting, but without having any of that, it's much easier. All right, sorry, it's much harder. So I need something, if that makes sense. All right, so basically we have the buffer memory here. I'm just going to add the full size of the buffer in there. So the bytes per pixel times the width plus the pitch times the height. So I'm just going to add in basically the entire size of the buffer. Again, do not worry about this code at all. I will be explaining renderers in detail when we get there, and I just don't want to belabor the point at the moment because it doesn't matter. All right. So anyway, here we go. You can now see that my jump code, awesome as it is, isn't even waiting for the timer to be set, right? Because it's just always working. And basically what I had to do is make it so that when this thing goes out of bounds, we don't crash. Because when it would go, it would be writing out of memory when we go here, right? So all right, so I'm tuning this. So I do this thing, and I'm like, oh, right, the timer is totally messed up. It's not right at all because it keeps going down. So I flip back here or whatever. I go, all right, so we got to do this game t jump thing, but that should only be happening basically if t jump is greater, is greater than some threshold value, like So basically, what I want to do here is say if game state t jump is greater than 0, then we will do this piece of code or whatever. Otherwise, we won't. So we'll do that. We'll do something like this. Right, there we go. And there. So I do that. Okay, I got an error there. Got to convert this to an int. Done. So I come back here, and now at least it's a little bit better, but I got to pick up the controller again. I got to get back to somewhere I want to test. I got to push the button. Oh, and the jump goes downwards, right? Not at all what I wanted. Sign goes downwards. Okay, all right. So stop, flip back here. I got to go ahead and say, all right, this should be going the other direction. I run it again, come back here, pick the controller back up, take my hand off the keyboard, do it, right? So you can see what I'm basically trying to say here. There's this whole process where I have to keep going like this is a problem because I got to pick up the controller, test the thing I want, go back to the code, change the code, come back here. And you can imagine if there was more state, like if there was an enemy, what if I killed the enemy? Well, now the enemy's gone. And so that firing the missile, and what if the missile I only had one missile left? Do I add a cheat key to add more missiles? There's all these kind of annoyances in there that make it not as smooth as I would want it to be, right? So what I would like to do instead is make it so that this can basically be like the way musicians edit stuff, right? I basically want to create something that's sort of like a loop editor where I can just go ahead and say, okay, I'm going to record something being done. And then I want you to just keep doing that thing over and over again exactly the way I did it as I tune the code for it. Does that make sense?
Yep.
So, I want to make something that's essentially like a loop editor but for code.
Interesting.
So how do I do that? Well, it turns out, like I said, if you architect everything properly, this ends up being actually extremely easy. Because think about how we have set up our game. If we don't care about sound for now, because we have a separate way that sound comes in, but if all we're trying to tune is stuff besides the literal sound output code, we only have one function that's called, right? It's called update and render. We know it takes the memory that's whatever the state of the game is. We know it takes whatever the input is on this frame, and then it just takes wherever we want it to draw to, right? Whatever we want it to draw. That's it. So if we wanted to, we could certainly start doing something relatively straightforward here by saying, all right, what if we just record whatever this new input thing is? We just remember whatever that is, right? And then we feed it back. Instead of actually producing the input, before we pass the thing here, we just actually see whatever the previous input thing was, right? We just record it and go. Seems pretty straightforward, right? So if we want to, we could basically introduce something, right, that captures this input. Because we know it's just a flat struct. We made it very simple, right? It's really trivial to capture. It's just one of these, right? So you could imagine having something that was like, you know, Win32 recorded input, right? You could imagine us constructing something that looked like this, right? There's an input stream, right? Something like this. And there's an input count, right? And it would basically say, all right, as we go, we just remember all of the inputs that we had, we stuff them in here, and then later when we want to play it back, we just go ahead and grab them out of here progressively. Right? Very, very, very simple. There's really nothing weird going on about that at all. Furthermore, if we wanted to, we already know how to do file I/O. So if we want, we actually don't even really need to do, excuse me, we don't even really need to store it in memory, right? We could just log it out to a drive and save it that way so that it was permanent, right? We could just read and write from a file. So basically, there really wouldn't be very much to at least that part, right? So let's think about how we might implement this. All I really need to do is sort of know whether I'm recording something, right? So maybe I'll have a variable here, and you know, I might want to record multiple of these or something. So maybe I could just introduce a variable here called like recording index or something, and recording index will be equal to 0, right? So when we're running, we also have a recording index, and that recording index is equal to 0. And similarly, if we were playing something back, maybe I'll have a playing index, like an input recording index and an input playing index, right? And basically, if these are equal to 0, then we are not playing or recording. But if they're equal to something else, then we'll think of it as like a slot, basically, that things are in. Make some sense? It seems pretty straightforward, right? I don't think there's anything particularly odd about that. So if we want to now, basically what I can do is I can sort of, well, I guess there is one, we do have a bit of a thing that's a little annoying here, which is that we kind of have our keyboard processing up here, and we'd like to start using that keyboard processing to affect some stuff. So it would kind of be nice if we had these things sort of starting to be centralized in something. So maybe, you know, I'd like to do something like this, which is Win32 state or something like this, where I have something like that, right? And that has some of these sort of globally sorts of things in it. So I have Win32 state, and that's here. And so I'm just going to go ahead and wrap those in a struct so that I can pass them around. Because basically what I want to do is I basically want to, excuse me, basically, I say basically a lot. What I want to do is I want to make it so that we can record things by just hitting a simple key. So basically, I look to see if we have hit the L key, let's say, for loop, right? And what we'll do is we'll take a look if the shift key was down. I don't know if, or what was the easiest thing to do? There was the alt key was down. So we'll go ahead and, well, actually, we don't even need that. I don't think we need that at all. If you press the L key, that'll go into loop mode, let's say. And then if you push one of the number keys, that will indicate what slot you want to record in. So we'll basically say we'll push L and then 1. We'll like start recording input to slot 1. And then you push L again and it stops the recording at that point, right? So L1 starts recording, L stops it, and then from then on, if you hit 1, it'll start replaying that slot, right? So let's go ahead and do it that way. For now, I guess what I can do is just hard code it so we don't have to do the 1, 2, 3 processing, because I can show you how to do that in a second. But so let's just say that if you hit the L key, then the Win32 state, the input recording index, right, becomes 1. If it already equaled that. So if it equals 1 already, or if it equals 0, it's that. Otherwise, we stop, right? Otherwise, we'll set it back to 0. So basically, we're just making a toggle here. We hit L, we start recording, we hit L again, we stop recording, and since we're testing here, we'll switch right to playing back as well. Make sense? All right, pretty straightforward, I think. Not much to do there. All right. So basically, I've got these playing indexes and that sort of stuff. Move those into here. And so basically, we just replace those with our own struct there. And we can start putting other stuff in there as well. So this will kind of be a nice holder for things that we want to be accessed outside. So I go ahead and do that. And now all I really need is I need to look at those when we're about to use that input, right? So right here, we have new input. And what I want to do is I just want to say, well, if the Win32 state, right, has a input recording index, right, if it's on, if recording is on, then I want to call something like Win32 record input, like this, and I want to record this input that just came in. And if the Win32 state is playing back something, right, then what I want to do is play back the input. And so I'm going to overwrite whatever new input was with whatever the input is, whatever I'm basically going to get, excuse me, whatever that thing reads from the stream of previous inputs, it's going to put it in there. Very, very straightforward, right? So we've got these two functions.
Missed the last bit.
Reads from the stream
attention.
of previous inputs, it's going to put and if the Win32 state is playing back something, right, then what I want to do is play back the input. And so I'm going to overwrite whatever new input was with whatever the input is, whatever I'm basically going to get, excuse me, whatever that thing reads from the stream of previous inputs, it's going to put it in there. Very, very straightforward, right? So we've got these two functions. Really, really simple. Again, nothing fancy happening here. Really all we have to do is implement these. Very straightforward. So I've got my Win32 state. I'll have to go change that to a pointer down there, won't I? And then I've got my game input. That's coming in here. So we've got those two things. That's our record input. Then I've got another one here that's going to play with the input back. Win32 state, this, and game input, new input. So there we go. And all I need to do is I just need to either write in the record function, I just need to write it to a file. In the playback input, I just need to read it from a file, right? That's it. So assuming that I have a file handle, which I could totally do, right? I'll have a file handle here, which is recording handle. And I'll have a file handle here, oops, which is playback handle. And we'll have to actually open these files with Win32 at some point. But I've got those, and so I'll go, all right, I've got this recording handle. So basically all I need to do is just write this out. And we already saw how to do this. Remember, we have our write file. In fact, we already wrote a thing that writes an entire file. It was just this, right? That's the entirety of it. We just need the file handle. So we need whatever the file handle is. We need the memory, which is the new input, right? We need the memory size, which is just the size of that struct, that new input struct. And then we don't even really care about the bytes written, because if it fails, it's just a bug code. We don't even care if it fails. So we're just going to try to write and hope that it writes, right? So that's it. So that's all we really need to do to write it. So we write that to the recording handle, right? That's it. And then the exact same thing happens with the read file. Right, read file. Where is that guy? That's the wrong function. There we go. So read file. Same thing again. So we basically have our bytes read. We don't really need to look at it right now. We will have to eventually when we want to get the looping stuff working, but that's in a second. So Win32 state, playback handle, I think is what I called it. Yeah, playback handle. And so then we just need to do the exact same thing here. We pass the new input, that's what we're writing. we pass the size of the new input, and we're done, right? So this is literally all we actually need to do to record and play back the input, right? That's going to happen. And then we also have the case of when we actually first start recording. So we basically have to do essentially something that goes back to the beginning of the recording or opens whatever this file handle is, that sort of thing. So we need something that's basically like begin recording input, or something like this, right? And then we'll need something also that's like win32 end recording input, right? We need something like that. And these will basically just be the things that get these file handles in the first place. So to begin recording input, we're going to just go ahead and do a create file just like we did before, to open the file handle with Windows, say, hey, let's get this back. So there we go. So we need to open our recording handle here. We're going to go ahead and create file. We want generic write privileges this time because we're actually writing to the file. In fact, I should copy the create file that we did for the other one, because that's the one we actually want to make a file here. So we have our file name for now will just be foo dot handmade hero, let's say. I don't know. That's probably a bad name. Handmade recording. Handmade input? I don't know. We're going to deal with that in a second, obviously. So we got our file name here. I never can decide whether file name should be capitalized, intercaps, or not, and I use it interchangeably in the code. It drives me nuts. I wish I had a consistent way of doing it. So basically, we go ahead and do the recording handle. We open that up. That's pretty straightforward. And we can even go ahead and say that recording, we'll pass that input recording index here, right? And we'll say win32 state input recording index equals input recording index. We'll do the open. And then in here, we'll do a close handle on that, and then we're done. All right. That's all we need to do. And so basically, these guys will move up here to above. I'm putting them above because we're going to call them in here, and I don't want to bother having to forward declare them. Things you wouldn't have to worry about if you were programming in John Blow's new language, because you don't have to worry about any of that stuff anymore. So that's going to be pretty awesome when that happens. But yeah, so win32 begin recording. It's going to begin recording input 1, and this will be win32 end recording input. And then it'll be win32 begin input playback, and it'll also be 1. There we go. So yeah, so that's really all we need to do. When we hit L, if we weren't recording something, we ask it to start. Otherwise, we ask it to stop recording and then to start doing playback. And so, we've got to do the equivalent of these two functions. And all right, there we go. Playback. Is playback? That's another intercaps one. Should it be playback or playback? You know what I'm saying? You know what I'm saying. I don't know. See, and I've done it 2 different ways. It's maddening when I don't know how it should be. I feel like there should be some kind of a style guide that tells you where there are the word breaks in playback, file name, that sort of thing. And so these are actually wrong now because, again, for closing the handle on the end of playback is fine, but we do have a problem where our create file is the wrong kind of create file. That's creating a write. So we want to copy, again, the one that we used for reading the file, this one right here. There we go. And that should be fine, because we're always going to open an existing one for our playback handle. So that's about it for those guys. So if you think about what that's going to do, right? When we hit that L key, we should start just recording our input to this foo.html file. Then when we stop that, we're going to start reading it again. Now,
Jeez, what your name is really hard. Is it call you RC? Prime buffer is another classic OpenGL one. Mumbai in the API. Prime buffer. I mean, looks correct, right? Capital B.
now, when we're actually doing the reading the input in our playback,
I mean, Rightfully so, because yeah, RC is fine.
phase where we're actually reading stuff, we do want to know when this starts to fail. Because when it fails, we want to go back to the beginning if we're trying to loop, right? So what we would want to do here is we'd basically want to do a Win32 end input playback, and then Win32 begin input playback, right? So we just want to do whatever the Win32 state, excuse me, whatever that input playing index is, we would basically want to store that. So this is our playing index. We'd basically want to just pretend that we stopped, even though we really aren't stopping, so that we close down the handle, and then we can go ahead and start again. And
I've got to make some notes because I will totally not remember all of it. Where's my input? I get the idea. I think it's... yeah. No note here. There was a key down. Can't remember. Key release. Is that a key down? Guess that would be fine. Could this be part of the game or of the platform? I'll put it here for now. So it could just be game. I'll put it here. Has been less. Why Zig? Because I'm trying to... I wanted to like pick a low level language. I thought of going back to C. I used to do C. But then I thought I should try something new. So between Zig and Rust, I found Zig to be a lot more familiar. So I picked Zig. We switched up the language and the platform. Yeah, it just happens to be the language that I wanted to learn and the platform I happen to be on. Plus it made more sense. Because knowing me, I wouldn't think if I didn't have to. I would just copy what Casey did. At least this way, you sort of have to force yourself to like figure stuff out. Has been less. Thank you. Okay, what do I gotta do? On L key down and I think it's 1 to, let's say 0. Start record, not recording. Else play. Okay. Where's the state? Jeez, can't type this morning. Handle. And I guess that's it. This would be good. File stuff is, I think, quite easy. Pictures we use. Where did it go? Yeah. Entire. Why did I just call it read file? Okay. I'll watch all of it first and then.
We could do it a little more efficiently than that if we wanted to, but I don't think we do because there's a bunch of stuff that has to happen during begin that we'll see in a little bit. So basically, I just want to set us up for success there, basically by making this.
Hang on. I also want to switch off audio for now. There's my thing. It's called play. What is the audio thing called? Oh, I can just mute it. Where's the volume? I think that should work. Yeah, it does.
And just use offsets off of it. So you can actually make.
Hang on, I just noticed. Okay, no, just still moves.
Make all of that work as well. It's just, again, the languages aren't set up for it. It's one of those sad things that just. It's why we need a new C. It's why we need John Blow to make his new language and for it to be awesome, because then we can just fix all these things, and then there'd be no stopping.
What was he talking about?
How can we make the playback work if we have no base address?
Hang on. How did I get there?
What I want to do is I want to make it so that we can record things by just hitting a simple key. So basically, I
Code up a file. Handle reading in the recording file.
it again. Now, when we're actually doing the reading the input in our playback phase where we're actually reading stuff, we do want to know when this starts to fail. Because when it fails, we want to go back to the beginning if we're trying to loop, right? So what we would want to do here is we'd basically want to do a Win32 end input playback and then Win32 begin input playback, right? So we just want to do whatever the Win32 state, excuse me, whatever that input playing index is, we would basically want to store that. So this is our playing index. We'd basically want to just pretend that we stopped, even though we really aren't stopping, so that we close down the handle, and then we can go ahead and start again. And We could do it a little more efficiently than that if we wanted to, but I don't think we do because there's a bunch of stuff that has to happen during begin that we'll see in a little bit. So basically, I just want to set us up for success there, basically by making this do it as if it ended and started again. All right. And there's that file name, intercaps, right? It's crazy, right? It's awful. All right. So basically, we're almost done. Surprisingly, for such an awesome feature, you're going to be shocked at how little work this thing is. All right. So we've got our Win32 state coming in now. We've got our record and playback happening when those things start and end. Playback input. What is wrong with that? Oh, that is Win32 playback input. I guess new input is already a pointer. That's the difference. So there is a couple little things. Again, I slammed that in there real quick. I just want to take a quick second. When we do begin recording input, this is supposed to be input playback playing index, right? Oh, I like when people on the stream say copy pasta. I've never really heard people say that phrase. It's kind of funny. When you cut and paste some code and you're supposed to be changing it to be some different code, but you don't. It's kind of funny. Anyway, so I'm passing this in, input playing index. When I close these out, when I do the end recording, I need to basically clear out those handles as well, right? So I need the input playing index to change to 0. I need the input recording index to change to 0 when you end, like that.
Actually, I do need to update. Change to read. And bytes. Yeah, because right now it reads the whole file. Can be removed. Set on file end.
And I think that's roughly everything that I wanted. All right, so let's take a look at what happens here when we do this. So I'm going to go ahead and just set a breakpoint inside that keyboard handler, basically, just so we can see what happens. So here we go. I'm going to run the game. I'm going to hit the L key to start recording. We're going to take a look here at our Win32 state structure, which basically should be just completely cleared to 0, which it is. Again, I always like 0 to be initialization, so you just don't have to worry about initializing stuff. You just clear it to 0 and you know that it's good. All right. We step in. We say, all right, it's time to begin recording. So we're going to go ahead and set the recording index to whatever slot we're recording into. We're going to go ahead and try and create a file. We created the file. Off we go. We pop out of here, blah, blah, blah. Nothing particularly interesting going on there. We go through our code, and we get down to the point where we've done all of our input processing. We say, are we recording? We are recording, so we step in here. We take a look at this write file. It looks like we're writing to a valid handle. We're writing out the input thing. Everyone is happy. We wrote 600 bytes. Is that how big our input is for a frame? We can check. Size of game input, 600 bytes. That's exactly what it should be. Everyone's happy. We come out of here. We keep going, and it's good. All right. So basically, this is writing out that stuff to disk, right? This is writing out everything that I'm doing. So if I hit L, in theory, this should now change to ending the recording input, which it does, closes the handle, goes in here, goes to start playing it again, creates that file, and off we go. So now we actually should, in theory, be playing back whatever the user input was for all the frames. Now, I don't know if it's actually working, and of course, I had left my guy sitting there for a while.
Yeah, I was thinking, do we need to not reset the game state as well? Or save the game state at that point?
So we would have to actually wait for a bit to see if this guy moves, but I also want to take a look. I really wanted to kind of look and see how that input code was actually working when it does the readback. So I'm going to go ahead and do this in a test where I know that I'm doing something when I hit that L key. So basically, L key. Oh, stupid mistake. And this may have cost us from having it work right the first time. I totally forgot to check whether the key is going down or up. I always forget that when I jump in here. So basically, it was triggering twice, once for the down, once for the up, which meant it started and stopped recording immediately, and that's not very much fun. All right. So basically, here we go. Let's try this again. I do the L key. I do the jump. I come back down. I push the L key. Hey, look. We're playing back our input. I don't know if it's actually working properly. It doesn't look like it recorded the jump, so I think we're still a little bit buggy, but at least it worked slightly. So let's go ahead and take a look at what I messed up, because I think we're almost there. So, all right. So when we do our recording, we are supposed to be writing write file. We're supposed to be writing this every time with our win32 record input, and then when we do our playback, we are what did I type? How did this happen? This is what happens when you explain stuff when you're trying to do it. You become an awful programmer, everyone. I promise you, I'm not as bad at programming as I appear to be on this stream. Like, if you actually look at this stream, everyone's gonna not want to hire me. They're gonna be like, "You're the worst programmer." Like, why would this? How did this get in here? This is totally wrong. Yeah. Okay. So anyway, basically what we did is if read file succeeded, we then started looping. That doesn't make any sense. Obviously, we only want to start looping when the read file is finished. I mean, that's kind of obvious, right? And read file, if I'm not mistaken, returns a bool. So it's going to be true when it worked, right? Yeah. If the function fails or is complete synchronous or 0. And I assume, I don't actually know, but I assume when it runs out of bytes, it will return false. Let's see. I don't actually know. I assume it will return false when it can't read all the bytes that you asked for, but I don't actually know. But what I do know is we could check for bytes read. So either way. So what we basically want to do is say, okay, if it read properly, note this is, there's still input, or here we've hit the end of the stream, go back to the beginning. So that was just fantastic. I mean, that is, high quality craftsmanship right there. Don't let anyone tell you otherwise. So I'm going to go down here and try that again. So we hit the L key for looping. We come down here, we hit that. I go walk back down here, and then I hit L. Hey, look. We just wrote input recording in 10 minutes. Cool. So, I mean, all right. I will point out that there was an entire company devoted to doing nothing but input recording at one point. They failed. It was called Replay something. I don't remember what it was. But basically, if you architect your code right, input recording and playback is literally like 10 minutes or 20 minutes of work. You just watched me do it while explaining it, actually, and it took only that amount of time. So it takes even less if you're not trying to do that stuff. Totally trivial. So the only question we have left is, how do we loop the state of the game, right? We got to loop the state of the game.
Okay, I think I kind of get the idea. Now to do it. Okay, I got to change a few things. Let's go put bytes to read. Can't be very big. Why do I create a file? I don't need this anymore. I think this might be I just get rid of this. Don't need that. I think I don't need the allocate. I should change this to don't need that. Shouldn't return file. Return destination. Oh no, hang on. I think this might not be right. Copy pasta. Get this is get file. Do I even need that? Because it's only 3 lines of code. No, I don't. How do I cast slice of bytes to, let's say, a struct? This is unnecessary. Return. Okay, hang on, before I remove that. I guess I still don't need this. Is there a right? What am I doing? Need that. What does this return? Why does this even need to be a function? Stupid. Alright, let's get rid of all of this. I think same goes for here. Yeah, I don't need this. Get rid of all of this. I think there's a better way to do it. Comment the tag. Game. What was it called? Looped input. That's fine. Let's call it that for now. We need read. Need write file. Are they the same file? Yeah, but I think the handle might be different. Would return. Not sure what. What the input was. Why do I need to play back? It's just game state. I'll call it current game state. What else do I need? I need the input key. Is that right? Alright, let's try that. See what happens. I guess we're either reading or writing, so I don't need a second handle. Oh, sorry, this is right. Oh, hang on. This can't be the same. Right file. I mean, they're going to be the same file, but they will be at different positions. Will they be? Yeah. Because let's say when you record, say file handle is like here. But when we, oh, no, sorry, the opposite. The input file should be if you haven't read it yet. Okay. Question is, how much input do we read? Do I want to read all? Where is reader? I think this is quite new. How do you use the reader? Is it reads size of the buffer? Yep. Okay. Returns a reader. We still need to pass it a buffer. Is there a way to know how big? Suppose I could just define how many inputs to read at once. Mm, Artist reader. Artist stream. Wait a buffered. Able boy H90. Is Handmade Hero a course or just Casey making a game? I think it's Casey showing like how to make a game from scratch without having to use libraries or game engines. Well, I mean, I think it's more like a course. Yeah, I would say. Where did I go? Well, let's just take a buffer. What? What do they use? R.stream turn out buffer. Can I just do that? Oh, there's already a buffer. Learn, read. Oh, read slice. So can that be the file? Set an example with file. Take this reader. Which version? No, I think this is the older version. Standard IO and standard read. You have an old stream and you need a new one. You can use that to new API. String buffers have a handy new API that are more convenient, perform better, and are not generic. For instance, look at how reading until delimiter works now. Well, reader.tick delimiter exclusive. Else end of stream, streams along read failed. Interesting. Unique concepts compared to language stream implementation. Decompression stream and blah blah blah. Without actually doing any memory copying, turning an operation into that. Okay, yeah, this is the one that I need. Memorizes key information about a file handles test size from calling stat or the error that occurred therein. Current seek position. The error that occurred when trying to seek. Whether reading should be done positionally or streaming. Versus plain variance, example read. Reader interface. Most code that previously was calling seek function on a file handle should be updated to operate this API instead, causing those seeks to become no ops thanks to positional reads, while still supporting a fallback to streaming reading. Set an exam. I mean, it would have been nice. Buffered right. I mean, it should be quite straightforward. File dot reader and read into something. And why did I pass it a buffer here? Positional is more thread safe. What's this buffer for? Init interface. Sweet table. I don't get it. Then why do you need a destination again? r.file.pread destination and offset. Not sure. Not sure how this works. I'd assume this would be destination. Can they both just be destination? That doesn't make sense either. I have no idea. Jeez. I shouldn't have deleted my previous read. What about frame buffers? Hey, what's the name? I wanted to thank you. Your input on the last stream helped me fix live code editing. I think it's just talking about naming, I think. I was totally looking at the wrong problem before you mentioned that it could be the build process. Okay, what am I doing here? Blah, blah, blah. Okay, that's much simpler. I can just read. What am I doing now? It's looped input. So when the game reloads, it replays saved inputs. So you can trigger a save. Let's say you press down the L key. It'll save all your inputs to a file, and you can replay it after you change some code. Pretty cool. What does it call it? Looped live code editing. Okay, I totally missed that in that case. Well, we'll check it out this time. Reset FD. Isn't that what he's doing? On hang on, I think I gotta open the video. Man. Yeah, it's quite long, but we'll check it out later. Automated testing and instant replays in retro game. City Rampage. Can I have a look at the... I guess you could use it for this, for same. You save the input that needs to be tested and the state. What am I doing? Self-dot input. Okay. Is it the start? And well, I mean, I'm not doing what's it called? Not doing much. It's like an easy stream today. This last few weeks have been rough. Actually, now that I'm thinking, why do I even need this? All this, for that matter. It's such a waste of time. This is one line. Where's the input? Here. No, I'll watch the video. I'm like, I don't want to write much code today.
So welcome everyone. Make sure to turn off your cell phones, put them on silent. And if you have a PlayStation Vita or a 3DS with Retro City Rampage DX, get that ready. VSync it would run in about 5.
I think
The input that the button presses and the keys that they press, and you have a deterministic engine, which means that if you record the buttons here, play them back tomorrow, they play back exactly the same. So this is about half an hour of the game playing in 15 seconds. And if I turned off VSync, it would run in about 5. So that's an example of me using it for automated QA. Because theoretically, you could run it after every single compile. So any change you make to the code, you can double check and make sure that everything is good and nothing's been broken. It gives you access to QA 24/7, so I think we've all been in the case where we're pulling an all-nighter to submit a milestone or submit some sort of deadline, and it saves you from phoning the QA in the middle of the night. And finally, it allows hands-on QA to be step 2. So you can kind of pre-filter things, run the automated tests. If they pass, then you get the QA in there to double-check things. And it's also incredibly multi-platform, so you can see that I ported to all these platforms, and all of these platforms work with it, including the previously unannounced MS-DOS port. So it's running here on a Pentium 1, and it would run on a 386 if I still had one. I also did another thing which I haven't talked about before. So does anyone have a Vita or a 3DS right now? Okay, if you do, you can enter this code on the main menu. So I started doing this around the time I finished the DX version, and I started including these automated tests within the game. So each platform can play through about 4 to 8 hours of itself at super speed, and it just allowed me to, up to the point of submission to certification, I can test the build and make sure that it's good. So use case 3 was indeed submitting to certification and all of that. Last year, I submitted 15 SKUs, which included 9 console cert submissions simultaneously, without bringing in external QA. Because it really slashes the redundant testing, because you will find in cases with consoles, depending on the regions, they require a separate ROM, a separate executable, completely separately compiled, but maybe the only difference is a product code or a network ID or something like that. And so it really allows you to really fully test one and then just automated test the other and then lightly test it. And also with resubmissions, I don't know about you guys, but on 2 occasions, on two different console manufacturers, I've had to resubmit to certification to change 2 bytes of data. So when you have your automated tests, it really...
I mean, I think this could be extended to do the same. Excuse me. So all that really is like input and the state. It's an extension of this. You could have like, instead of writing it to an input file, you could call it like a test file. Yeah, then it's all, I would say it's the same thing. The only difference is this is more for like debugging than for testing, but you could do it. That mean you'd have to like play the whole game once. Maybe. Yeah, I guess that could work. And you can just like combine the whole thing after. And you can extend it to just keep reading file after the next. That's pretty clever. Yeah, I would say. For you to write the test first kind of removes that. Yeah, I'd agree. I think it makes sense. Well, plus, I mean, this way you don't need to write the test at all, which I like. Because writing test first, I don't know, I've never been very successful with it. Okay, symbol. How do I get? Can I just do? Oh. I think this style is fine. I don't know if this What is this? Okay, I need to end cast. You're 32. Is recording. Yeah, I could use, I'll save, do the same. So that only thing is your game engine has to be deterministic, or your tests need to save delta time between updates. Keep that in test reply file and inject into update func to replace delta time with each call. Yeah, true. I mean, even right now, I was wondering how that would work. Need another type. Where do I initialize this? Okay. Do I allocate? Yeah, I do. Yeah, I was wondering the same thing. When I save it, how do I know sort of the time? Like how long something should be playing for? Not yet, but somehow, maybe it does. I don't know how the time thing would work. It's a good point. We work on ticks. So instead of, okay, so there be no like idea of frames. Each frame would be like a tick. Oh no, there would be an idea of frames, but don't need to worry about the FPS. Or you could speed it up. I have to try it to really understand. Yeah, a single FPS. Draw multiple times on one update tick. Yeah, that is quite interesting. Wonder how that works. Do I need input file? Dot read file. What is it? Read file. File. What is it called? The update logic is decoupled from the draw. Yeah, same. I think Casey does the same as well. How do you open a file? Hey, Volcanistics. Nice beard. What do you mean? I just shaved a few days ago. Got no beard. Just a directory dot. There we go. I think I'll just save it in the same directory for now. Looped input dot handmade. Yeah, I think this one is read only. I think that's the default. Thank you. Refactor print. Yes, this returns a file. Yeah, it is. This will be the same file with a different flag. Dot. Okay, dot open mode equals write only. What is the flag? Oh, it's called mode. Okay. What else do I need? Are you a little bit into Bash? Maybe. I don't know. Never really thought of that. I don't know. Let's say yes or no. Let's say yes. Yeah, maybe a little bit. Why do you ask? Well, actually, no. I've never really been into Bash. I think this is unnecessary. This recording is replaying the both defaults. Inputs. Don't need that either. Gave them looped input. So I think now I can key symbol. Hey, Warren Buffett. How's it going? Oh, it's a Sunday, so it's a bit of a easy day. I'm just setting things up. Half record, P for play. Yeah, okay. Looped input dot is recording. SQL is here. You in Australia? No, not far. I'm in Thailand. Dot is recording. Maybe to do allow write to files 1 through 9 or 0 through 9. Why are you in Australia? So you could write inputs. Need to do something there. And here, copy this. Supply in, and if it's yeah, okay. Yeah, it's 6:30 on a Sunday in the morning. Oh, maybe it must be quite late for you. Oh no, maybe late evening. Oh, but the US is quite big, so it could be like mid-afternoon. It's plain what to do here, so I don't know what to do in 1:30 in Germany. That makes sense. Oh, it's Sunday for you too then. Okay, what do I do here? If it's recording. Oh, actually, this shouldn't be here. Should be here, I think. Actually, why didn't I just save the whole thing? Git release time. Yeah, that makes sense. Game looped input. Dot write file. Dot write. Needs bytes. Can I just do? Oh no, can't do that. How can I write this struct? Don't know if I've ever done that before. Metacast, floatcast, incast. Oh, maybe I can do this. Expression and get T. Global keyboard input. Yeah, I think that should work. Should. What does this do? Maybe I can save. I think 32 is fine. Not sure why I would need to do it. Bytes, and I need buffer. I think it would be best to just overwrite the file. By buffer. And this is not right. I could make it slicer that struct. Okay. Keyboard input. It's called. It's called game input. Oh, this is called input. I think I need to rename that. To game input. Makes more sense. I mean, it's pretty ugly at the moment. We'll sort it out later. Game input dot read buffer. Will be kind of lost at the moment. What am I doing? I found the tweet. Needs a buffer to read into. Can I just make this an array for now? I swear Casey made it look so easy. Should have paid more attention. Should go back and watch. I'm doing too many things. Read. Dot. I mean, and it should fit because it's the same size. Why not try? But red should be equal to the size of game. Dot read buffer dot len. It is called size of, right? Yep. I think do the same for geez, why it's so hard to name stuff. Right. Wow. That's better. I'll rename this to input by thread. This would be right buffer. Do I even need to read this? Yeah, kind of do. This is all like, it looks so nasty. I think I need to rewatch what Casey did. Maybe tomorrow. I'm like quite lazy. Just left it halfway. Okay, let me just finish this. Okay, loop dot written buffer. So I can continue updating the same file. I guess. Instead of the read. Hey Taras, long time no see. How you doing? This is all kind of shit. And overdone. Needs redoing. Okay, so that means, what does that mean? Why did I even do that? Okay, so I've updated whatever was in there. So I tell myself. Then now, it should be here. And then this, I'll figure it out later. So if it's recording, looped input dot, I should rename that. Buffer. My buffer of what is equal to global keyboard input. Okay, not very complicated. And then just write the buffer. Okay, you know what? This is too long. Just gonna call it GLI. Did I not rename this? Okay. That should kind of work. And then playing that is a whole nother problem. Read from... Well, I think it's kind of obvious what needs to be doing. I don't know how to like play it. Oh no, this is wrong. Should be GLI. Yeah, save the whole thing. It's okay, it doesn't need to like stop program. I don't know. All of this kind of looks shit. I think it's way too complicated. Doesn't need to be. Okay, I'm gonna redo this tomorrow. I am way too lazy. This is supposed to be like a chill day. Yeah, I'm gonna watch back and pay attention next time and redo it. Yeah, that's a good idea. I'm gonna call it a day. There. Yeah, I'll see you back here tomorrow. Hope you have a good weekend. And yeah, I guess that's good. Yeah, have a good weekend. I'll see you back here tomorrow. See ya.